Good morning. Today we are going to do max and min application. So actually we have done stuff like this before in secondary too, but we're going to involve calculus in this. So we want to watch out for the procedure and everything like that because, as most of you know, when we deal with story problems, they're all different in their own little ways, but the procedure is the same, okay? So after we read our problem and we see what we're doing, drawing is a huge thing. As you can see in the first example I'm going to do with you, we already have the drawing for us. So once we have our drawing, we're going to choose our variables, make sure to label what they mean because your X might be different from your person right next to you that has an X, okay? So make sure that you're labeling that. Then what we're going to do is we're going to figure out if what the formula or equation we're going to use for the problem that helps us. Now, sometimes there are two, okay? This is called a secondary equation. What happens is it helps you with the first. I will explain that as we go further. Then we're going to rewrite our equation, our primary equation, with one variable. Okay, we are not doing our implicit differentiation. Okay, so that's why a secondary equation sometimes is involved. So that way we can get our primary equation to have one variable. Then we're going to look at the domain because we always have to make sure that we have our boundaries. We're going to take the derivative, find the critical numbers, and make our sign right. Now, why do we do that? Well, because where do we get max and min, guys? We get it from the first derivative. So let's check this out. A box with no lid is made from 48 centimeters of material. Before we read that, when we talk about material that's covering a box, what are we talking about? We are talking about surface area. Okay, and what I'm pointing that out right now because that's going to help us with making our equations, whether that be the primary or the secondary, I don't know yet. If the box must have a square base, what does that mean? A square base. That means the length and the width are going to be the same variable, right? Because square, the sides are the same length. Find the dimensions that produce a maximum volume. So this is what we're trying to find, is a maximum volume. So actually, our primary equation is going to come from what we need to find. So our primary equation is going to be our volume. All right, let's label. Let's remember, it's a square base. This, of course, this drawing does not look like a square base, but remember, drawings aren't perfect. If you see me draw this box, it won't look pretty. So we have our length and our width, we said, are the same variable. So I'm going to label length and width as X. And I'm going to label the height as Y. Okay, I labeled that. Now we got to figure out our primary equation, okay? Primary comes from the volume. How do you find the volume of the box? Well, volume is length times width times height. Now, of course, I'm going to involve my variables in here so I can stick with my x's and y's. So really, that comes out to be x squared times y. Where did I get that? Well, length is x, width is x, x times x is x squared. Okay, so this is good so far. But I know I have a problem here because I have, yes, I have volume, but I have an x and y. So I must use a secondary. Where does the secondary come into? Well, that's from the surface area. One thing I want to remind you is when you come to your secondary equation for this problem, we have to remember that it's an open box. So we have no lid. So we only have 5 sides. Well, let's look at this. So the bottom is x times x, which is x squared. So surface area equals x squared. And what do we do with surface area? We add all the areas together. And then we have these four sides, and there's four of them technically because x and x are the same, right? So x times y, we have four sides that are x times y. All right, so what we're going to do right now is we are going to use the secondary equation to put into the primary equation. So if we look at this, what variable is easier to solve for in this equation? It's going to be y. The other thing I also want to show you, which I haven't done yet, is I have not put the 48 in for the surface area. So now when I rearrange and I solve for y, let's see, I get 48 minus x squared equals 4xy. Get y by itself, divide by 4x. So we get 48 minus x squared all over 4x equals y. Right here, we can actually talk about domain before we plug it in, right? Because what can't we have? Well, we would never have a zero length anyways. And what is our max for the area, for the surface area? It's 48. We'll talk about that in a little bit. Keep that in mind. Okay, now what I'm going to do is substitute in. So our volume here is x squared times, now instead of y, I'm going to have this 48 minus x squared all over 4x. Okay. Now what I'm going to do is I'm actually going to make this look a little bit better, so that way when I take the derivative, it's not all messed up. Remember, always simplify as much as you can before you take your derivative. Okay, so I'm going to break this 4x into both of these, and then, oh, let's do this. Better idea. X squared and 4x down here, what happens? We can cancel out an x. We can distribute that through. And then we can divide both of these by 4. So I get, let's see, that's 12x minus 1/4 x cubed. Now it looks a little bit easier to take the derivative. Take the derivative. Let's see, that would be 12 minus 3/4 x squared. We want to find our critical numbers, remember, and that's by setting our derivative equal to 0. Probably the easiest way to solve this one, guys, is just to isolate x. So we get negative 12 equals negative 3/4 x squared. Divide both sides by 3/4. We get 16 equals x squared. Now be careful, because some of you guys made this mistake on the last test. When you solve for x here and you take the square root, how many answers do you actually get? You get 2. You get plus or minus, oops, 4. What am I doing? Don't use pen while doing math. Okay, so but we're talking about a situation. So we got to talk about what works and what doesn't. So as you can see, we're not going to use negative 4, right? Because we can't have a negative length. So x equals 4. And this is when we do our sine ray. So 4 is going to be on there. Okay. Now we have to keep in mind our domain, right? So of course, the lowest we can go to is 0. What is the highest we can go to? Well, surface area. We still have surface area if we just have the bottom. Okay, and by the way, if we go to 0, do we have a box? No. So this is, of course, going to be parentheses when we talk about that interval. And the same thing down here. It's not 48 we're talking about because we have x right here. It's the square root of 48. Because we got to think of both sides, right? All right, now we do our summary. So negative, positive. We have to go back though because there's a trick to this, because if we look at our function is negative. That leading term, which would be right here, is negative. So we need a row of negatives. And I see that we have a max at 4. So go back to the question. It says find the dimensions. So not just 4. So we have x equals 4. In which equation can we plug it into to find our y? Well, of course, we can plug it into our secondary equation, which would be our 48. I'm going to do it down here so it's easier to solve. 48 minus 4 squared all over 4 times 4. So we get our answer of 2. So our dimensions are 4 by 2. All right, one more. Find the product. So what does product mean? It means multiplication of 2 positive numbers. So that helps us with our domain. That is 228. Find 2 numbers so that the sum of twice the first plus the second is as small as possible. So we have our minimum. Right away, I'm going to label my variables. So x is going to be my first number. Y is going to be my second. All right, so primary comes from where I want to solve. So my primary comes from down here. So we have the sum, so we're adding the 2 twice the first number. So twice the first number would be 2x plus the second, which is y, is as small as possible. I'm going to say this is the sum, so that way I know what I'm talking about for my first. Okay, which means this product here is my secondary equation. So the product, so x times y is 288. Again, I knew there was a problem or a secondary equation because I have x and y. And remember, before we take the derivative, we want to make sure we're in one variable. Okay? So I'm going to use my secondary and solve for one of these. In this case, I'm going to solve for y again because it's just alone. Well, not really alone, but it doesn't have a coefficient in front other than 1. So y equals 288 all over x. I'm going to substitute in. So I get the sum equals 2x plus 288 x. I'm actually all over x, which I'm going to put this up so I can do the power rule a little bit easier. Does everybody see what I did? I moved the x in the denominator, put it in the numerator, and made the exponent -1. Now, I realize that x here has to be greater than 0. Not only do I know it from the secondary, but I also know it because it has to be positive. So I always want to remember that x has to be greater than 0. Okay? So does y. X and y. All right, let's take our derivative. So I get 2 for that power rule. Now this power rule would be negative 288 x to the -2 Okay. I'm actually going to rearrange this so it's easier to solve, because what do we have to do next? We have to set it equal to 0 to find our critical values. So 0 equals 2 minus 288. And I'm going to bring that x squared back in the denominator. Now I'm going to solve. So bring the 2 on the other side. We get negative 2 equals negative 288 all over x squared. I don't like fractions. Nobody does. So let's get rid of the fraction by multiplying both sides by x squared. I'm going to show where I'm going. So I get negative 2x squared equals negative 288. X squared equals 144. Square root both sides, we get x equals plus or minus 12. But we know from our domain that x has to be the positive, so it's going to be positive 12. So now that I know that x is 12, I can plug in right here to find my y value, which tells me y is 288 over 12. I can keep it like that, or I can reduce this to 24. I understand that many of you can guess and check some of these problems, but if you do not use the calculus, you will not get the points for them if this were an FRQ. Okay, try some of these out. Remember the primary and secondary and being able to recognize them.